This video is so that if you weren't able to hear me, if the internet was cutting out, if you couldn't make it to the meeting today, or if you just need to see a certain problem again, you have a chance to do that. So I'm gonna go through the whole thing. You can pause as you need to so that you can write this down, watch it again if you need it. Here we go. So this is to prepare you for the test on Friday on chapter 3. On this first problem, it says which lines are parallel. So remember that we look for which ones are transversal. Let me use a highlighter, different color. Okay, so if we have the angle 141 over here and 141 over there, they're both on line Q. That means Q has to be our transversal. And that means that the line that Q is crossing, those are going to be the ones you're checking to see if they're parallel. Since these are both 141 degrees, they're both obtuse, and they're alternate exterior angles, then X and Y are going to be the ones that are parallel for sure. So you're just going to put X and Y. Those are the lines that we're showing are parallel with these angles. Then the question on the end says, give the reason why. So the reason why is going to be those converse. So like this was alternate exterior, you'd put alternate exterior converse. Converse is where we're trading the hypothesis with the conclusion. So the original alternate exterior angles theorem says that if you have parallel lines, then the alternate exterior angles are congruent. This is reversed. Because these two alternate exterior angles are congruent, then we know that these are parallel. That's why we're going to make sure to put that word converse on these when you're saying why are they parallel. So on the second one, same process. You look at the angles 98, 98. Those are both on line Y. So that means Y has to be your transversal. And then the relationship here is corresponding. They're both down and to the right. So they're both obtuse. They're supposed to be the same. They are the same. Then you go, okay, well, A and C have to be the lines that are parallel. So A and C. When it comes to the reason, it was the corresponding angles that told us they were congruent. So it'd be the corresponding angles converse. Don't forget the word converse, super important. Number 3 is asking you what are the 4 converse that you can use to prove lines are parallel. We already use alternate exterior and we already use corresponding angles. So it's alternate exterior angles converse, corresponding angles converse. There's also alternate interior angles converse. There's also consecutive interior angles converse. The little symbol I'm putting right here is replacing the word angles so that I don't have to write so much. Next piece of it, it's asking, are these congruent or supplementary? Pretty much you can just look at, are they obtuse? Are they acute? Or is it one acute and one obtuse? So like angle 1 and angle 3, angle 1 is acute. It's a small angle. Angle 3 is also acute. So these vertical angles, they're congruent. I'm going to use that symbol for congruent. The little equal sign with the squiggle on top, congruent. 7 and 3. 7 is obtuse, 3 is acute. They're different. There's no way they could be congruent. So this linear pair is supplementary. We'll put SUPP for supplementary. Then you have 7 and 4. So 7 is obtuse, 4 is also obtuse. That alternate interior pair, it's congruent. They look the same, they are the same. Then you have 6 and 4. Obtuse, also obtuse. On top of that, they're corresponding angles. Corresponding angles are supposed to be congruent, and they are, because we're dealing with parallel lines. For angle 1 and 2, angle 1 is acute, angle 2 is also acute. They're congruent. That alternate exterior pair of angles are congruent. And then number 3 and number 4, if you look at 3, that's an acute angle. It's less than 90. 4 is an obtuse angle. It's bigger than 90. So if it's acute and obtuse, there's no way they can be the same. So we're back to supplementary. That's the only other option because these two lines are parallel to each other. For the next piece, it's asking to classify. I've given you guys the list over here because this is a review. On the test, since we're doing distance learning, it's going to be multiple choice because it's going to be on quizzes. But this list, so you know, if we weren't in distance learning, would not be on the test. So 3 and 5. 3 and 5 are right across from each other, right across the vertex. That's vertical angles. Angle 6 and angle 3, they're right next to each other on the same vertex. You're not crossing the vertex. You're just right next to it on the same one. So this pair is making a line that's linear pair. Then we have angle 1 with angle 3. Angle 1 is on this angle. Angle 3 is over here. So the transversal is this top line. I don't care about anything on the bottom. Angle 1 is up and to the right. Angle 3 is up and to the right. They're going the same direction. That's corresponding angles. Number 1 and 15. So now we're looking at 1 over here, 15 over there. Now our transversal is this line, so we don't care about anything on the left side. Angle 1 is on the right side of the transversal, 15 is on the left side of the transversal. They're both outside the parallel lines. Well, not parallel, but the lines, these two lines. So alternate, because they're across. External, because they're on the outside. Oh, sorry, exterior. My bad. It's like 5 in the morning. Okay, 12 and 15. 12's over here, 15's over there. Transversal's going this way. Ignore the whole top piece. So 12 and 15 are between these lines, that's interior. 12's on top of the transversal, 15's on the bottom, that's alternate. So you go alternate, interior. Then we have 6 and 12. Now we're going this way. My transversal goes up and down. Ignore everything on the left, on the right side. So 6 is on the right, 12 is also on the right. So it's not alternate. They're both on the same side of the transversal. They're on the interior, so it'd be corresponding interior. And that one can also be called same side, interior. That's another name for it. Number 6, when you're stating a reason, these already have the parallel lines. So you're not going to say converse. You're going to use these, and they're going to be theorems. So if we have angle 3 and angle 2, they're right here next to each other. You can say LPT or LPP. Some people will call it a postulate, some people call it a theorem, but it's linear pair. If you're looking at angle 3 and angle 2, they're supposed to be supplementary. That's what this tells you, is that they add up, they equal 180. That's supplementary. If you're looking at 3 and 6, angle 3 is on one vertex, 6 is on the other one. They're on the same side of the transversal, but they're on the interior. So that's going to be corresponding interior angles, there we go, theorem. For angle 7 and angle 6, they're both up and to the left. If you kind of think of it this way, up and to the left, they're the same direction. So my bad. This is consecutive interior, not corresponding. Wow. Okay, 7 and 6. 7 and 6 are corresponding because they're going the same direction. So corresponding angles theorem. For 3 and 1, 3 is on the left side of the transversal, 1 is on the right side. That's alternate. They're both between these parallel lines. That's interior. Alternate interior angles. I don't know why there's a T there. Angles theorem. Angle 2 and angle 6. 2 is on the right side, 6 is on the left side of the transversal, still alternate. They're between these parallel lines, interior again. Alternate interior angles theorem. Sorry that it keeps going out of focus. Angle 3 and angle 4, they're congruent to each other here. They go across the vertex. That's vertical angles. So this would be vertical angles theorem. Pretty common to put VAT. So it says draw or describe a real life example of parallel lines. So a real life example, if you want to describe it, you could say railroad tracks. Railroad tracks on a straight section. Because I'm going to be real specific here, because you know how train tracks, sometimes the railroad tracks are straight and sometimes they go around a corner. So those aren't lines at that point, only when they're going straight. So that's why I'm going to say the straight section. But there you go. There would be a real world example. You could also say 2 lanes on a street, on a straight section. That's also a good example. The top and bottom of your monitor, the top and bottom edge of your computer monitor. That's another example. So any example that's talking about 2 lines that go the same direction, that would be a real world example or a real life example of parallel lines. You have to go the same direction. Over here is where you're gonna wanna have your calculator ready. Oh, come on, focus. Yoo-hoo. You could do it. I have faith in you. All right, I don't have faith in you. All right, I had to pause the video to adjust my settings. Sorry about that. Number 8, those alternate exterior angles are both obtuse. Remember, they should be the same, so they're congruent. The way you're gonna write the equation for that, make them equal to each other. Then with your algebra skills, you're gonna add 3 to both sides. So you're gonna have 5x equals 120, and then you're gonna divide both sides by 5. Your x is gonna be 24. It also says state the reason. I mentioned these are alternate interior angles. So your reason, alternate interior angles theorem. You already knew they were parallel. That's why it's not the converse. It's theorem. Number 9, these are on the same side. One's obtuse, one's acute. So these are not equal to each other. That means they have to be supplementary. So you're gonna write 5x minus 3 plus 82 together equals 180. Then you're gonna combine like terms. So if you add those together, that's 79. Then you're gonna divide both sides by 5. I need a calculator for that. I got 15.8. And the relationship here is consecutive interior angles. So it'd be the consecutive interior angles theorem. Number 10, they're both acute angles. So just like these two obtuse angles, they look the same, they are the same, make them equal to each other. 3x equals 51. So you're going to divide by 3. X equals 17. And the relationship there is going the same direction. That's corresponding. So it'd be corresponding angles theorem. Then you get to number 11. That one's acute. That one's obtuse. They're not the same. So it's like this, where they add up and equal 180. So 3x plus 120 equals 1. Wow. No, that's right. That's right. Okay, cool. So acute, obtuse, they're different. I added them together. I equaled 180. Awesome. Subtract 120 from both sides. 3x equals 60. Divide by 3 on both sides. X equals 20. That would be called same side exterior angles. We haven't really talked about that, unfortunately. I'm going to put it here. That's why consecutive interior is sometimes called same side, because then you have same side interior and exterior. Man. If you put NEI or none, that'd be okay, because I haven't talked to you about this one. Sorry about that. But that rule about acute and obtuse, they're different, so they add up and equal 180, still works. Even if it's a pair of angles that don't have a name to them. All right, number 12. It's asking, are these lines parallel? So you have to know something about both lines. Like on this one, we don't know anything down here. So we don't know if these angles are congruent, supplementary. We don't know anything. So this one, you would say NEI. And it's because we don't know anything about the bottom. No info on bottom line. That's my reason. I don't know about the bottom line. On the second one, now we have something about the top line and the bottom line. So now we can look at it and go, they're alternate interior. They're both acute. They look the same. They are the same. So that one, are they parallel? Yes. And then Y, remember the word converse, because we did not know they were parallel to start with. So this would be alternate interior angles converse. Don't forget that word converse. Number 14, we have info top and bottom lines. So we can look at this one and go, that's consecutive interior. They should be supplementary. They add up to 180, so they are. So, yes. And the reason why, consecutive, interior angles converse. Don't forget the word converse. Number 15, once again, we don't have any information on the bottom. So even though those are supplementary and that's wonderful, they're linear pair, that's not enough to tell you that the bottom line is parallel to the top line. So just like number 12, not enough information and no info on the bottom line. Should have left more space. So there's those. Remember that you're saying why are they parallel, so that's why it's converse and converse. Oh, almost skipped over some. Number 16. It says, what X value will make the lines parallel? Well, these are alternate exterior angles. They're both acute angles, so X should be the same. when it comes to justifying, it'd be because we would want to use the alternate exterior angles converse. So the alternate exterior angles converse needs the angles to be congruent. They have to be the same. Number 17, it says shade in a plane that is parallel to ABC. So if I see ABC, I'm talking about this one over here on the left. Parallel plane, I just go to the right. It's going to be this plane right there. That'd be the parallel plane. So I'm going to shade in the left side so you can see it a little bit better, but I'm going to use a highlighter. Hopefully that helps. Those two planes are going the same direction. They are parallel to each other. The proof. So I mentioned yesterday, and it's in the slides for the notes that I gave you yesterday, that if it was given to you, all you're going to put is given. So right here it says C is parallel to D. Well, it's right there. It says given. It was given to you. Angle 2 is congruent to 1. That's also given to you. Angle 1 congruent to angle 3. That's not. So now we have to look at the drawing. So angle 1 and angle 3, those are alternate interior angles because A is your transversal. They're on parallel lines. So that's how you know that they should be congruent, because alternate interior angles. So alternate interior angles, theorem. It was already parallel, so do not put converse. Then for angle 2, congruent to angle 3. Now, if you went like that, there's 2 and 3, but there's no parallel lines. So that's not because of the corresponding angles. What actually happened is right here we had angle 1 and angle 3, and above it we had angle 2 and angle 1, and those two angle 1s connected the 2 to the 3. So that's transitive property. And now we know that these are parallel, but it wasn't given to you. You're saying they're parallel. So this relationship was corresponding angles. It's going to be corresponding angles converse. And we use converse because it did not start telling you that these were parallel. Number 19 says draw parallel lines M and N with the transversal X and alternate interior angles 1 and 2. Take one piece at a time. Draw parallel lines. They're called M and N. Put little arrows to show that they're lines. And then it says with a transversal X, transversal goes across them. That one's called X. And alternate interior angles 1 and 2. So alternate interior would be, here's one interior, and then over here, alternate crosses that line. I can go like that. So that's drawing the parallel lines, M and N, with transversal X and alternate interior angles 1 and 2. Last problem on this review. Joe says corresponding angles can never be supplementary. Is he correct or incorrect? Explain. So the corresponding angles, let's look at this drawing. Corresponding angles would be like this angle 1, and then if I had one right here, those should be the same if the lines are parallel. But if you think about it, remember, if you have right angles, right angles are both congruent and supplementary. So is he correct? Incorrect. Incorrect. Period. And it says to explain. And you can just say right angles are congruent and supplementary. So you could have angles that are congruent and supplementary if they're right angles. That's the only time it happens, but that is a counter example. So remember, you can pause the video, you can rewind it, watch it as many times as you need to. Good luck.